So one piece of advice I would have is that we, and by we I mean just the field of science and universities and funders, the entire ecosystem, we should prioritize research questions where a null or negative result would be informative, right? We shouldn't only prioritize research questions where it's only the positive stuff that gets published or that is seen as interesting. So going back to the acne and jelly beans cartoon, I mean, I think the real problem there is not that somebody tested 20 colors and reported one. I mean, if they had reported what happened with all 20 colors, you could have made of it, what that was worth. But the real problem is that studying acne and jelly beans is not an interesting question in the first place, for the most part, right? I mean, it's not as if, people who study skin conditions think that the color of jelly beans is like the central problem of their field. This is the sort of question that is only interesting if you come up with some exciting headline. It's not interesting if you come up with what is otherwise, expected and no result, right? If you publish that purple jelly beans don't cause acne, no one's interested in that because they would say, of course not. Why would you ever even think that purple jelly beans cause acne? It's irrelevant. There's another, and I say this resembles nutrition though, because there's a nutrition paper that I wrote about at one point. This was conducted by a set of scholars at Harvard, headed by Walter Willett. He's one of the most highly published and recognized nutrition researchers in the world. And this study, as it was published in headlines, said that teen girls who eat peanut butter have a higher risk of breast cancer later in life, in their 30s. And I thought, well, that's interesting. So I dug into the study, and it turned out they weren't really talking about breast cancer. They were talking about benign lumps. But more importantly, they were talking about this kind of long-running longitudinal survey of girls to women who it asked them in their teens about the foods they ate. It asked them about something like 160 or 180 different kinds of food and how often they ate those foods per week. And then, as it followed them into their 20s and 30s, it asked them about a bunch of different health conditions as well. So you ended up with, as I recall, something like 10,000 different possible correlations between foods or food frequency earlier in life versus some health condition later. And so, the same authors, Walter Willett and his team, used this exact same survey and all these different possible correlations to also publish results related to alcohol use and later benign breast lumps. Exercise. I mean, a bunch of different possible correlations to report there. And I think the problem is, of course, if you look at something where there's 10,000 different possible correlations, you're going to find something that meets a p-value of 0.05 just by chance. But the bigger issue again is that this is not a theoretically interesting question in the first place. It's not as if the field of breast cancer researchers is saying, please, nutritionists, will you finally study the question of peanut butter? Because if only we could, discover what peanut butter is doing, then we would finally solve breast cancer. I don't think that's happening at all. No one in the breast cancer field is looking at peanut butter as the primary cause of breast cancer. So this is just like a chance correlation that's only interesting if you come up with some exciting positive result to say you've discovered some cause of breast cancer. It's not interesting if you report the other 9,990 things that aren't related. So I think that both reproducibility and innovation are harmed when we try too hard to avoid null results, or when we study questions where the null result isn't interesting, right? So reproducibility, many of these reproducibility problems arise from the attempt to come up with positive results at any cost, or from the impulse of journals to publish only the positive results. In innovation, it also is affected because true scientific advances, I think, can't be made without a lot of false starts, a lot of null results along the way. And if you only study something that's guaranteed to work, it probably won't be a breakthrough. Like if it was already guaranteed to work, the breakthrough would have happened sometime in the past, right? You can't commit to a future breakthrough by saying it's guaranteed to work. That just doesn't make any sense. So I think we need to place a higher value on publishing null results and a higher value on studying questions where null results are in themselves interesting or a sign of some sort of progress towards an ultimate scientific finding. Another thing that I think we ought to be thinking about, and this is more of a systemic issue that funders and universities should think about. I don't think it's that individuals can necessarily do anything about this on their own. It's more of a system-wide problem. But I think we need to find ways to reduce the level of hyper competition for grants and academic positions. I think in many fields, professors take on too many PhD students and postdocs, often because they're seen as someone who can work on your own research projects, right? But they take on too many in the sense that there's not enough kind of turnover in the academic positions, and there's not enough growth in academia for all of these PhDs and postdocs to ultimately find a job. And so you end up with a kind of hyper competition for the few academic jobs and the few grants that are available. And so here's a quote, actually a couple of quotes from an article by some kind of famous scientists in America, like Bruce Albert, Shirley Tillman, Mark Kirshner, et cetera. It's called Rescuing Biomedical Research. And they point to the damaging effects of hyper competition, both as to innovation and as to reproducibility. So they say that biomedical scientists spend far too much of their time writing and revising grant applications, far too little time thinking about science. The low success rates, they say, have success rates in getting grants, that is, have induced conservative short-term thinking. And so the system now favors those who can guarantee results rather than those with potentially path-breaking ideas that by definition cannot promise results. Seasoned investigators are inclined to stick to their tried and true formulas for success rather than explore new fields. So there you see it's kind of hurting, hyper competition, they argue, is hurting innovation because it's causing everybody to fall back on what's safe and what they're sure they can get funded rather than something that's possibly more risky because it might fail. And they also point out that hyper competition can hurt reproducibility as well. So in the middle of this paragraph, they point out that the inflated value given to publishing in a small number of so-called high-impact journals has put pressure on authors to rush into print, cut corners, exaggerate their findings, and overstate the significance of their work. So I think this is a really interesting and troubling phenomenon. I think competition works well in some areas of life, like athletics, but in athletics you have kind of an immediate feedback loop where you can see who won, who scored more points, who ran the race faster, and so forth. And so there's kind of an objective measure of performance in most of athletics. And again, there's a clear winner and loser, and so it incentivizes the people to try their best and to train, to prepare for whatever it is, the Olympics and so forth. In science, it's not as clear that there's a winner and a loser. It's not always clear who's going to do the work that leads to a breakthrough. As I said, a lot of scientific work has been in the past, has been serendipitous and unpredictable. There are lots of discoveries made in basic science that aren't really recognized for 10 or 20 years. So that's a very difficult place in which to have true competition. I mean, it's a place in which if you introduce too much competition, people end up falling back on kind of cheap and easy metrics like publications and citations and studying more safer topics. And as I say, ends up probably hurting both reproducibility and innovation.